Hello, I'm going to talk you through the introduction to measuring and predicting. It's largely looking through a Word document which you'll see on the screen in front of you. I'm going to be adding a few things to the notes that are given, and you should try and pick up on what I'm saying in order that you can answer a few questions that there'll be at the end in one of the assessments. You can typically see the sort of question that's going to come up because it'll be asked in the text in the notes. So if we continue through, then first of all we've got a contents listing for the whole course, which you can look at your leisure. The first part to this is the introduction, which is what the Word document's about, and I'm going to talk you through that. There's various exercises and videos to watch for the other sections, which are measurement and predicting. But the introduction is largely me talking and you looking at a document. Within the introduction, there's 4 small sections just explaining what the course is about, and in order to really answer that question we need to consider what is research, and to answer that we need to know what can we actually teach, and then we'll just look at the course content and your research project, particularly how it's going to be assessed. So the first of these things then, what's the course about? We have to come up with clear aims and objectives, which is actually something I'm going to return to again and again as we're preparing you for your research, which also has to have clear aims and objectives. For this course, the aim is to prepare you guys for independent research, and particularly independent research in environmental science. It's a fairly generic thing to be able to do research, and we'll cover the generic nature of it first of all, and then make it a little bit more specific to cover environmental science research in particular. Environmental science, of course, is a pretty generic subject in itself, so a lot of the things that we'll be talking about would apply to anyone that's doing research, and then to anybody that's doing an awful lot of different sorts of research. But hopefully we'll be able to pick up on something that's specific to environmental science. The things that you should take away from this in order to achieve this aim, we need to provide a generic framework for carrying out research. So we need to discuss first of all what is research, which will be the next question. We're going to train you in some techniques that are widely used. Can't cover everything, but actually many research projects use very, very similar techniques, and so it's worth us mentioning those in particular, and quite often they're not used well. So we'll be covering things I think that you'll have covered before, but I think we really want to try and maybe raise the level of understanding of why and how you use them. This arises from lots of cases where we meet with external examiners, whether for PhDs or for the MSc programme, and they'll often criticise the generic technical skills that you guys have. We tend to over-focus on the knowledge that's imparted to you through these courses, the specific knowledge, but the transferable generic skill of how to do research, which is a thing really that's probably going to be most used to you, because the jobs that you go out to do may not, or are unlikely to, wholly coincide with the specific thing that you've researched on. But your generic ability to be able to do research is the most critical thing, and you need to really understand some techniques for doing that. We can't cover everything, but there are things that are used again and again and often misused, so we'll be covering those. Need to understand how to make measurements and control and recognise the quality of the measurements. Those two things go hand in hand. Really, making a measurement actually means also understanding the quality of it. In doing this, we inevitably have to have some examples to look at. The examples that we choose are hopefully ones that are of fairly wide applicability. So that's, we've got these general background physical and chemical concepts that form the basis of many environmental investigations. We'll be assessing the course ourselves by asking some questions at the end of it, and the particular thing we would recognise it as being a successful course if you were to actually retain the notes from this course and the specific examples that you could then use as a resource as you go into employment. So you might take the examples, and by tweaking them slightly you could actually reuse them. And we can decide whether that's the case by the time you finish the course. Why is the course called Measuring and Predicting? That's because that's effectively what you're going to do as a professional. The predicting part is easier to understand. Ultimately, you're most likely to get paid money because of your ability to predict. The simplest thing of looking at that is if you're able to predict what's going to turn up on a roulette wheel, then you're going to make some money. Or if you're going to be able to predict what horse is going to win a race, you'll make money. Similarly, if you can predict what the concentration of a contaminant is going to be at some time in the future, and you can make a prediction that's correct, then you'll make money. Or if you can predict what the contaminant concentration is going to be at a particular distance away from the site of contamination, again, you'll make money. So prediction is ultimately what's going to pay the bills, and part of that, in order to be able to make the prediction, you need to make some measurements, and we're going to see how actually measurement and prediction can effectively be the same thing. But you need to be able to do those two things. You might think the simpler thing is be able to make the measurement, and maybe that's the sort of thing that a technician might be able to do, but then using the measurements in order to predict what's going to happen is where you have the professional scientist. Now, all these things blur into each other. Also, I'm insulting technicians, but there's no technicians here, and we won't tell them. The next question, how does this relate to environmental science? And we're going to try and cover that. What specifically is relevant to measuring and predicting environmental science, and why does this matter to me this year? These things in italics are things that I'm actually asking you to think about and come up with an answer to, which you might have to then write a short answer to in the assessment. What do scientists do? Well, certainly at the university, what we do is to do research, and to understand what research is, one of the main ways to do that is to consider that the university, the currency at universities is research. The funding that we get and the funding that individual academics get into their own pocket, in other words their salaries, is closely related to their quality and quantity of research. For something to count as research, there's various different grades of research when we talk about quality. The highest quality research is research that's published in a peer-reviewed academic journal. And peer review means that it's been assessed by colleagues, typically colleagues that work in a similar area, and they've decided that this is research. That's perhaps the most cynical way of looking at what defines research, but that's the way that universities work. And an important thing for you to recognise is that you're at a university, you're going to be assessed by the university system and by people that work at a university, and you need to, if you think it is a game, then it's a game that you need to play in order to get the mark or the degree quality that you'd like to get. As far as what we can actually teach you, noted that the Beatles didn't go to pop star school. I know One Direction effectively did go to pop star school, but perhaps they're different really in how long they're going to be remembered for, and the influence that each of them's had. Not that I'm a great fan of the Beatles, really. However, the point is that there's a lot that we can't teach you. When you consider what research is, without patronising you, many of you will think, well, it's what I see going on the telly or on a film with people in white coats that do something that saves the planet. Now, or it's Einstein, or it's a Nobel Prize winner. Now, the inspiration part of research is not something that we could say we're qualified to teach you. What we can do, though, is teach you research as a process, and it's important to recognise that it is a process. And as it's the only thing that we can teach you, really, which is the process, it's really also the only thing we can assess you on. So we're not expecting something inspirational and Nobel Prize winning. You don't have to do that in order to get a first class or a distinction, because we're not qualified to teach you that. There's an argument we could have about whether we could teach that and how we might do it, but in the standard way of teaching and the things that we do at this moment, we're not able to teach you that. And that doesn't mean that it's hopeless and you shouldn't come to university, because what we can do is to teach you the process of research. So understand we can't teach you the magic, if you believe there is such a thing, but what we're going to do is teach you the process, recognise it as a process of doing research. If you want to look into this a bit further, recommend these books that are listed. There's some copies in the library of these. Thomas Kuhn's book is one you've probably heard of already. It's the way that science progresses and the way that new revolutions in science come about, and effectively thinking about how the inspiration happens and whether it is just a matter of the old people that thought one thing eventually die and then there's room for new ideas. John Gray's further, well, more pessimistic really, about how we have new ideas and how they move forwards. And John Waller's book, which I can very strongly recommend, goes through some examples, Darwin and Eddington, proving that Einstein's theory is right, and I think Fleming as well, and some very well-known bits of science, and looks into the way that those massive scientific discoveries actually happened, and whether we ascribe relevance and the fact they were correct, or whether we ascribe that after the fact. It's very, very interesting. Recommend that you have a look at that. We'll be working through then, first of all talking about measurement and then moving on to talk about prediction, and to point out that actually the research that you might do could actually be just making measurement, if it's a sort of measurement that's not previously been made. You might give an example of a research project, something that would count as research but was actually only making measurements. Identifying what's special about measuring and predicting in environmental science particularly, and we'll go into this in more detail when we go into the prediction part of the course, but fundamentally the thing that's special about environmental science is the systems that we're trying to measure or predict the behaviour of are very complex systems. Also, the amount of data that's available on these systems is limited because of difficulties in access and making environmental measurements, and we can't do experiments. Very rarely can we do experiments on environmental systems. You can probably figure out why that is, but we'll cover that in a little more detail in the prediction section.